education company a little over a year ago with my friend and co-founder Amrita Vasan. I'm also a PhD candidate and researcher at the Stanford Graduate School of Education, where I research and understand the learning affordances and educational opportunities of immersive virtual reality. A lot of the research I do at Stanford is what led to the founding of this company. And I'm really excited to talk to you a little more about what we know and what we are doing on the research front, and how we are bridging research and industry through this company. My email address and my Twitter handle is up here. At any point of time, please feel free to reach out to me directly or reach out to our team at inspiritvr.com if we can help answer any questions, or if we can help collaborate or work together on any front. As a company, we're launching an entire STEM curriculum and science platform in a month or so, and we're looking for partners, teachers, parents, educators, administrators of every kind to work with us and to help us refine and improve our product in the coming days. So let's get started. The goal for this presentation is on the research front. I want to try to talk about and throw some light onto how we design, develop, and understand the true and real educational merits of immersive VR, because VR is a very loosely defined term that can represent a range of different topics. And I want to try to demystify and talk about what we definitively know VR can do for education, and what we still need to do more work on to really understand the educational opportunities for. On the product side, I want to also talk about the challenges and the infrastructural barriers to taking cutting edge research and making it a tangible product that you can then scale and deliver to a large number of users around the world. We focus exclusively on K-12 and higher education, and both these spaces bring their own unique set of challenges and opportunities as well. And I want to spend some time also talking about how we deal with them through InSpirit. Before I begin, I want to just start with talking with just a definition of virtual reality and how we think about VR. Everything I say in this talk is going to assume that VR is so real that your brain thinks it's real. You may, for example, have experienced a walk the plank VR simulation where you wear the headset and you are asked to walk on a plank. Very simple stuff. It's an animated CGI world. You're asked to walk the plank, and you know for a fact, the front part of your brain, the cortex, knows for a fact that this is a fake world. It's not real, right? I mean, it's an animated computer-generated image. And of course, I shouldn't feel any kind of fright, right? However, the moment we ask you to jump from this plank, the moment you're told to take the final step outside the plank, the rear part of your brain, your fight or flight response generator of your brain, has not sufficiently evolved to know the difference between what's real and what's not real. So that will generate the same physiological response in your body as if you were jumping from a real plank. In other words, your conscious brain knows that this is not real, but your subconscious, your unconscious brain is fooled into believing that this is a real experience. And in social psychology, we call that presence. One of my advisors at Stanford is Dr. Jeremy Bailenson, who runs the Virtual Human Interaction Lab at Stanford. And this is kind of how he thinks about VR. And in his lab, this is one of the first demos we do to get you to really understand and realize the power and potential of this technology. Presence is really everything, is how I like to think about it. The moment you can establish presence, you can really put a user in very visceral, very engaging, very deeply immersive experiences that can lead to positive changes in behavior in the real world, that can lead to other effects and learning outcomes. For example, I can put you in the shoes of a superhero, which is another simulation we do. And this is a photo from the VHIL lab at Stanford, where you're a superhero flying around a city, trying to save a child in a city that's on fire. We are able to measurably demonstrate an increase in altruism if you participate in altruistic activities such as this in the virtual world. And this is really incredibly exciting and also very interesting to study, because who would have thought that spending just 5 to 7 minutes inside a simulation of this kind can lead to behavior change in the real world that persists once you take off the headset. I could also, for example, take you to the bottom of the ocean and have you understand and see how the coral reefs are dying out due to an increase in the acidification of the ocean. If you look up the Stanford Ocean Acidification Experience, this is a photograph from that tour, and the experience does exactly what the title says. It's looking to educate learners about the challenges of climate change, and we're able to again measurably show changes in how students think about climate change, changes in biases, in perceptions, and stereotypes, and also in attitudes, which is also super interesting, because we have really not seen such powerful effects of many other technologies in the past. VR is also a very compelling tool to put you in the shoes of somebody else. And here is an example from one of the VR experiences from the lab again, where you wear the headset and you're now in the avatar or in the virtual body of, in the case of this photo, an African-American young boy. And you're asked to wave your hand, and then you have a mirror in the virtual world that responds actively to you. Now, the whole point of this exercise, again, is to establish presence, where now you, at the end of this task, you believe, or you subconsciously believe that you're embodying the avatar of that person. And following that, if you experience a day in the life of that person, experiencing microaggressions, experiencing small changes in receptivity, in things that people say to you in your day, we can measurably see changes in your attitudes, in your perceptions, in your behavior in the real world, just by virtue of spending a few minutes in these virtual simulations. So that's really interesting. This is not how I got started with VR. My journey with VR started outside the laboratory and outside formal research environments. In 2015, I had the opportunity to work with the Google education team. And this was around the same time that the Google education team was taking out the Google Expeditions virtual reality platform. For those of you that do not know what Expeditions is, it's a collection of 360-degree images and field trips of various parts around the world. And it's designed to teach you about topics in history, geography, and science by taking you there as if you were going on a virtual field trip. These work on smartphones using Google Cardboard headsets, and it was really a breakthrough innovation and technology, really ahead of its time in 2015. I was lucky to lead a team that took this to Mumbai for an entire summer, where our goal was to really study and understand how we could integrate this technology into an extreme low-income urban school. We spent an entire summer studying and working with the teacher and all the stakeholders there, understanding the infrastructural, social, technical, traditional values, and the intersection of all these dimensions to make this tool work in the long term. And it was fascinating. We had students build their own Google Cardboard headsets, use recycled phones, and we were able to demonstrate and see a very high increase in engagement, in interest, in confidence towards the topic area, and also an increase in what we called inquiry-based learning, or an increase in the students' ability to ask questions that were deeper and a little more meaningful in connection with the topic that they were studying. So when they were learning about history, for example, we had a tour of the 7 wonders of the world, and we noticed students developing a deeper sense of engagement and questioning attitudes towards that topic in history by virtue of, again, just spending 5 to 10 minutes in these virtual field trips that were just still images, not even immersive simulations, which was really interesting. This is what got me excited about VR. And then the next year, I was back then a student at Georgia Tech in Atlanta. And so the next year in Atlanta, we decided to pilot another study where we took the reverse angle to VR integration. We wanted to see how learners, students, and teachers created and became creators of VR content. Because when you engage students in the creation process, you tend to learn a lot about the design principles and the strategies that need to be taken to make this work in the long term. And in the case of this study, we had students build stories and movies on topics like hunger and homelessness in their neighborhood, which was a challenge that they saw every single day in their lives. And VR was a tool for them to tell stories from first-person perspectives, a day in the life of a homeless man on the streets of Atlanta, and really build a deeper sense of empathy, a change in biases and attitudes that you have towards these topics, and to build a deeper level of inquiry and critical thinking towards that topic. This again reinforced all the beliefs I had in the power and potential of this technology. And it was around this time when I launched InSpirit with Amrita, really to accelerate the pace at which we could bring the best of what this technology could offer to schools. Um, the third study that we ran in schools was in Cobb County in Georgia, which is a district just outside the city of Atlanta, where we integrated an introductory biology curriculum in 4 different public schools over the course of an entire month. We had the students spend just 5 to 10 minutes every week immersed in a magic school bus-like VR experience where you would shrink in size and enter a eukaryotic animal cell. And you would explore the organelles and the parts of the cell as if you were flying through it and touching these things and learning how they were structured and organized in relation to one another. We were able to, through this activity, see very high increases in critical thinking, in self-efficacy or confidence towards biology, and a deeper level of retention in the long term. So far, all these studies that were conducted looking specifically at virtual reality delivered through Google Cardboards and a smartphone. There are limitations of this technology when you deliver VR in the very basic hardware range. And I want to talk about that for a little bit of time. The goal of VR really in STEM education is to bring that interactivity, that experiential learning, that curiosity-driven learning, which STEM education is totally missing right now. However, I was really struggling to see why there was no VR effort out there, either through a for-profit company or a non-profit organization or even research that was able to scale an effective VR solution in schools. And it was largely because we were depending heavily on the smartphone, Google Cardboard like VR platform for delivery. And the challenges of these devices are really a lot. These devices, if you spend more than 10 minutes in a Google Cardboard headset, no matter your resilience, it can lead to headaches, it can lead to motion sickness, it can lead to nausea. And this is because the alignment has to be totally perfect for you to get it right. It's a very powerful experience, and the Google Cardboard can be clumsy at times, it can be gimmicky at times, it can be a little dizzying and disorienting to learners. And as a result of that, once we left the research site of all these studies that I described to you, almost always the technology ended up collecting dust on the shelf. It almost never was able to deeply be integrated and see a long-term use in any of these environments. At the same time, this is data that was collected through many organizations out there like Samsung and Oculus, where they saw that there were instructors, over 2/3 of instructors around the US, just the US alone, who were looking for new ways to engage students. Students were unhappy with the current STEM learning tools. And the most powerful statistic that I saw at this time was that more than half of the students who started a course in STEM, whether an online or an offline course, ended up dropping out of the course before finishing it. So attrition rates were very high. And this was largely due to a lack of reinforcing fundamental concepts, a lack of building confidence and self-efficacy, which led to stereotype threats and other challenges that students felt and feared and dealt with as these topics got more and more complex, as you build on the fundamental topics with more and more complex topics. And you'll see that most of these dropouts tend to happen in the community college, early undergraduate years, or at the late high school years, which is when things start to get a little more intense. And at the same time, as I had briefly mentioned earlier, the reason VR was just not working in schools and colleges was because of the dependency on this hardware that was clunky, that wasn't really ready yet. The 6DoF, or the high immersive VR headsets like the Oculus Rift, the HTC Vive, were just not were just too expensive for schools. And that was the reality of the fact. They were too expensive. Schools could not afford to have these in the classroom. In terms of other challenges, budgets were limiting. Forcing teachers to use VR inside the classroom was another big challenge. So one thing that every teacher knows out there is they are really strapped for time. There are so many pressures on a teacher to deliver a syllabus in a certain amount of time, to complete certain deadlines and milestones. And a teacher really very rarely has the time in a classroom period to do VR. So these were kind of 3 reasons on the technical side. And then on the content side, it seemed like content was just not truly immersive and interactive. The Google Cardboard experience was largely passive. It was a 360 video or an image. And you rarely ever interacted or real-time performed decisions. It was not an active learning experience. And we had enough evidence in the learning sciences literature that if learning is not active, you really are missing out on a very large part of the entire learning experience in the classroom. InSpirit was launched really trying to address these 4 challenges largely. We are a premium VR solution, and we are trying to really bring about that learning by doing attitude in the classroom, that exploration, that curiosity first approach to learning science and STEM in the classroom. We have built an entire collection of physics, chemistry, and biology labs, as well as the entire software ecosystem to integrate virtual reality into existing school systems. So whether a school has a MOOC or a massive open online course, a learning management system, an LMS, or any existing digital infrastructure, our platform can seamlessly integrate into those, and we bring with it an entire collection of science labs and science simulations that would just be very difficult to do in the real world, either too expensive, too difficult, or just impossible to do in the real world. Our labs are designed to be short, and they're aligned with standards. They're customizable, so they can be very easily aligned with almost every standard out there. We have lesson plans and assessments that are integrated into every simulation to better connect VR to the learning experience. Very rarely do we focus on what happens right before and right after the VR experience. And we have to realize soon that VR is just one thing that a student does in the classroom. And VR is often situated in context of a bunch of activities that are happening before and after. And they play a very big role in how VR can better further the learning experience. And so we try to do that by integrating lesson plans, assessments, and aligning with standards. We have an entire instructor dashboard for classroom management to offer the teacher tools to see grades, to assign activities, and to allocate customized assessments. And I'll talk more about that in a bit. And we are hardware agnostic. And this was really important. We are not building our own hardware. We are purely a software platform. And our goal is to sit on consumer devices out there. Probably the most wonderful thing that happened to virtual reality in the last 2 or 3 years was these high-end VR devices have significantly dropped in costs. And we are banking on building exclusively for the high-end devices because the motion sickness is significantly lower in them. They're significantly more robust. They're more heavy duty and can sustain rough use in a school or in a classroom. And they're becoming more and more affordable and accessible. And I'm talking about devices like the Oculus Quest, the HTC Vive Focus, and also newer ones like the Rift S and the HTC Vive Pro. To give you some examples of what we are doing with InSpirit, here's an example of some stills from our biology simulations, where we again take you into the microscopic world and we teach you DNA replication, DNA translation, protein synthesis, and you physically are lifting and moving around the various proteins or the various molecules to construct and to understand the process as these different chemicals interact and engage with each other at the microscopic level. In physics, we've built what we call physics playgrounds, where you have the ability to pick up objects, throw them, and look at the free body diagram of that object, or look at the trajectory of the object as it flies real time. And then on top of this experience, we also allow students to manipulate parameters here. So for example, as a student, I can change the texture of that ramp. I can change the mass or the materials of that object that I'm throwing. And I can then learn about friction when 2 different objects collide with each other. I can also change gravity. So I can also understand what it's like throwing the same ball on the moon versus throwing the same ball on Earth, trying to build that physical intuition for Newton's laws of motion. So before the student jumps into doing the math equations with the various equations and the formulas that they have, you want to build that physical intuition that can lead to a deeper sense of retention, deeper confidence, and more critical thinking on the part of the student. In chemistry, similar to biology, we have the ability to zoom into the microscopic world, as the bottom picture shows. That's a still from our states of matter lesson, where you look at the molecular structure and the atomic structure of elements across different states of matter. We have a periodic table lesson where you can play with the table of elements and again understand what organic chemistry molecules look like at the molecular level, and then also perform macro reactions and experiences in our chemistry lab. Experiences or reactions that might be too dangerous to do in the real world. For example, we have tested efficacy and engagement with recent pilots. So before the COVID-19 school closures, our team was running a bunch of pilot studies in schools and universities in the United States. And these are just a couple of studies that I'm showing up here. We saw very high increases in student engagement through an increase in the time spent in these experiences, completing activities, engaging with their peers, and solving problems real time. As well as a long-term retention and critical thinking and confidence levels significantly above other control conditions that were measured against VR. All of this was just through very short dosages of VR, often almost always never done in the classroom, but delivered in a science lab or a library, or in many cases also as homework that the students did at home. And this opens up and makes it really flexible for a teacher to also integrate and meaningfully use this in the classroom. This is what our platform looks like. Along with content, we built an entire platform because this is super important for a teacher or an instructor to make this really usable on an everyday basis. A student can log in through the learner portal, a teacher can log in through the instructor portal. If a student logs in, they see their dashboard, which is a unique dashboard for each student where they can look at assignments that are assigned to them. They can complete a simulation, and as they're doing the simulation on the left side of the screen, on the right side is a worksheet that they can solve real time that the teacher has assigned to them for that specific class. So as a teacher, she can align this with her standards, her curriculum, her lesson plans, and can essentially customize the same labs to fit it into the everyday lessons that are being taught in the classroom. And then the student is actively engaged in a problem-solving task in virtual reality. On the teacher side, she can see her entire classroom. If she's teaching 5 different classes, she can manage the database of her students, look at grades of the tasks that they have completed, and she can assign new activities to them with a customized worksheet. We have our own pre-built worksheets on the platform, but as a teacher, she can also assign her own customizable worksheets with a due date, as well as other kind of everyday features that a teacher usually needs to give to her students. All of these simulations are designed to be group activities as well. So there is a group feature enabled too, where you can have multiple students solving this together in a virtual environment. And in the future, we want this to be a social VR experience where students can solve and complete an introductory lab exercise, for example, in this virtual space together before they jump into the physical exercise in the school. By no means is any of this looking to replace what's already happening in the classroom or in the lab. Very often, we believe VR is the best used when it is used for short dosages. It is self-paced and it is used for practice. So our chemistry and our physics and our biology labs too are often almost used as homework tools. Because we're hardware agnostic, we also have built our platform to be supported on MacBooks, on laptops, and on PC devices as well. So as a learner, you can also access these on a 2-dimensional interface. And there's also a lot of academic evidence that shows that learning via virtual simulation that are not necessarily on a headset, but on a 2D screen can also lead to very high learning benefits like increase in critical thinking, active problem solving, if the content is designed in a pedagogically sound way. At every step, we try to be true to our research. And so I'm going to put a pull here, Sayer, asking you to visit our website at inspiritvr.com or email us directly. You can email Amrita, my co-founder, or me. We're running a bunch of focus group sessions over the next 2 months because we just want all kinds of our stakeholders to give us more feedback and help us improve our platform before we launch our 4 years or 3 years worth of research work in the fall. August the 1st is when our platform goes live. You can pre-order it today as well. But more importantly, we are looking for you to participate in our focus groups and our conversations and our ongoing conversations to help us refine and improve the product. I would love to also help answer questions at this point of time, and I'm always available at those 2 email addresses below. Thank you so much for giving me this opportunity to present, and I hope you all have a wonderful day ahead. Bye-bye.